මොකක්ද මේ තියෙන්නේ? හරි නේද? කට්ටිය උදව්. Good morning everybody. අද කොයි පැත්තෙන් යන්න ඉර පෑවේ නේද? අනගි ඉතින් පාන්දර නැගිටලා ඇත්තේ ඉන්න. කාදාවත් නැතුව. Good morning Netmi. How about the Manju? Anagi. Watida. Anindu. Asin. Asin berarti kan nih kalau kita sedikit aku sekarang hantaran ini deh. Kita kira demo mana saja. Kalara. Oh mandana asin ini kira. Mandal galang personal dokter hambur nih. Lagi mendeknya itu kita so last day we were doing probably set theory beginning. Good morning. And I gave you about 3-4 sums as examples, and I remember we discussed two of them, and the third is an easy sum, just to practice the properties of the rules of set theory. Discuss so we can do that today. Hi, the last question I gave is this. I gave 3 like identities to prove identities in set theory, right? The third is this A minus B intersection C. You have to show that it's equal to A minus B union A minus C. This is something very easy. So anyway, let's discuss it, work it out. This is අපි වැඩිපුර කරේ මේ කලින් පාඩමේ ඔයගොල්ලන් තුන ප්‍රශ්න බලවලනේ. Like you start from the left hand side, the identity answer A minus B intersection C. This is the last question I gave last day. And this minus we can replace by A intersection B intersection C dash. So we have a rule A minus B is equal to A intersection B dash. We can use this rule here to get rid of this minus, right? Good morning to you. බලගෙන ඉන්න පාඩම මේ අපි දාම් කියන විදිහට ගන්න. So we got rid of this minus using this, and now this dash. At once you should remember De Morgan's law. Using the De Morgan's law, you can express it as B dash union C dash. That's De Morgan's law. Now, two operations, intersection and union. So you can like expand it using the distributive law. This is De Morgan's law. Here we have used De Morgan's law. Then distributive law, using the distributive law, you can expand it. So A intersection B dash union A intersection C dash, right? Distributive law. Now, A intersection B dash is nothing but A minus B. Union A intersection C dash is again A minus C. So that's the answer. That's the proof. ප්‍රශ්නයක් එනවා මොනවාද distributive law එක A union B intersection algebra වලින් කියන්න බැරිද මේ rules හැම තැනම තියෙනවා නම හොඳේ මේ ගන්න හදාගන්නකො මේක ඉවර කරන් මම උගලන්ට කියනවා I remember I like explained something similar to that last day. The thing is, the rules we yeah. Yes, I understand your question. This is how the rule appears. This is how the rule appears in set theory. The same rules, all the rules that we discussed: commutative law, associative law, distributive law, identity law, then idempotent law, De Morgan's law, some other complement law. All rules යෙදෙනවා අනිත් ගොඩක් තැන්වල. Even in vectors, apparently different, but the same rule, right? So this is how the distributive law appears in set theory. So if you go to vectors, in vectors say A dot B plus C, the dot product and some addition of two vectors. So it will appear as A dot B plus A dot C. Distributive law. මම අනිත් ඒවා පැත්තට තියලා මේක ගැන විතරක් explain කරන්න. That I mean the other rules, commutative law, the associative law, laws like that. For the moment, we'll take this. So this is how the distributive law appears in the vectors, right? Vector algebra, and in matrices, අපි ළඟදී කරන් ඉන්නේ A into B plus C equals AB plus AC. In matrices, in real numbers also, it will appear the same form. A into B plus C equals AB plus AC. In Boolean algebra, මේ මොනවාද IT කරන ළමයි කීප දෙනෙක් ඉන්නවනේ අපේ පන්තියේ. ඒ අය ඉගෙනගෙන ඇති. In Boolean algebra also it appears the same form. In Boolean algebra, the first rule, the commutative law. In vectors, A dot B equals B dot A. The dot product obeys the commutative law, right? But A cross B, what about A cross B and B cross A? They are not equal. So the cross product of vectors does not obey the commutative law, right? එතකොට මොනවාද in Boolean algebra දැන් මොනවාද De Morgan's law appears in set theory in this form: A intersection B dash equals A dash union B dash, or A union B dash equals A dash intersection B dash. Hari in uh, in in uh, in Boolean algebra මොනවාද IT කරන ළමයි ගන්නට in Boolean algebra A B bar equals A bar plus B bar, or A plus B bar equals A bar into B bar. That's how the De Morgan's law appears in Boolean algebra. එකම දේවල් නැවත නැවත යෙදෙනවා, right? අපි කිව්වේ මොනවාද identity law A intersection phi equals A, sorry, is phi in real numbers, A into 0 equals 0. It is the identity law in some form, right? ඔබිට මේ rules ටික හැමතැනම තියෙනවා. හරි? ඔයගොල්ලෝ තව level එකකින් එහාට pure maths ඉගෙන ගන්න ගියොත් තේරෙයි. මේවා හැමතැනම හම්බ වෙනවා. හරි? මම ඒක නිසාමයි පැහැදිලි කරේ. level එකකින් එහාට විශේෂයෙන්ම මොනවාද කියන abstract algebra ඉගෙන ගන්න ගියොත් මේවා හැමතැනම හම්බ වෙනවා. Very interesting part in mathematics, right? Abstract algebra. ඉස්සෙල්ලා ඒක හොඳට පාස් කරලා ඉන්න ඕනේ. එතකොට වාසනාව ලැබෙයි ඒවා ඉගෙන ගන්න. බොහොම ලස්සන දේවල්. අන්තිම මට කියන්නේ ඒවා ඉගෙන ගන්න නම් මේ ගවර්න්මන්ට් යුනිවර්සිටි එකට යන්න ඕනේ ආ. කොළඹ කැම්පස් එකට පේරාදෙණිය, උද්‍යාවදනපුර, කැලණිය වගේ යුනිවර්සිටි එකට යන්නම ඕනේ abstract algebra වගේ ඒවා ඉගෙන ගන්න. Right? Okay, so now we have one last topic in set theory, which is about subsets, right? Subsets. Subsets. නෑ මේ රූල් සමහර තැන් වලට හරියනවා සමහර තැන් වලට හරියන්නේ නැහැ. දැන් මම කිව්වේ commutative law එක cross product එකට හරියන්නේ නැහැ. dot product එකට හරියනවා in vectors, right? එතකොට මොනවද distributive law එක in vectors A intersection B union C equals A intersection B union A intersection C, right? අනිත් පැත්තටත් හරි A union B intersection C equals A union B intersection A union C. ඒක දෙපැත්තටම වැඩ කරනවා ළමයි. But in real numbers, A multiplied by B plus C, distributive law appears in this form: A into B plus A into C. Even in vectors you can write like that. ඒක අනිත් පැත්ත හරියන්නේ නැහැ නේද? මොනවාද? A into B plus C. මේක කරන්න දැන් A plus C into A plus B plus C කියලා. It is not valid here. This is okay. මේක පොඩි කාලේ ඉගෙන ගත්තේ නේ. But not this. ඒක තමයි හරියන තැන් තියෙනවා හරි නොවන තැන් තියෙනවා. සමහර තැන් වලට හරියනවා. Right? Right, subsets, subsets of a set. Right, you are given a definition. Given two sets A and B associated with the same universal set, right? A comma B are sets sets of the same or sets associated with the same universal set, right? My question: under what conditions or conditions you say A is a subset of B? Under what condition or conditions you say A is a subset of B? Here, brother, we say A is a subset of B if, what is the requirement? To say A is a subset of B, the requirement is all the elements of A should be in B, right? Yeah, they have to be non-null sets. Yeah, A comma B, they have to be a non-null sets to speak about subsets, right? But not null sets. Make one of the subsets and null sets. ඒක සම්බන්ධ වෙන තැන මම පස්සේ විස්තර කරන්න. දැන් පොඩ්ඩක් කොහොමද? හරි? ඒක අපි එතනට එන්න ඕන. Subsets and null sets. Right. We say A is a subset of B if all the elements of A are in B, right? All the elements of A are in B. That means anything belongs to A should be in B, right? If X belongs to A implies X belongs to B. If X in A, X is in A, then it's in B also, right? So under this condition, we say A is a subset of B. And it is denoted by A is a subset of B, right? Now look at this definition. Look at this definition. But if B is also A, B is also A, B is same as A, still won't this be valid? In other words, under this definition, can't you say A is a subset of A? Won't that appears under this definition? A is a subset of the A. The definition is anything in A. If anything in A is in B also, we say it's a subset of B. So isn't it valid for A and A? Yeah. So under this definition, A is a subset of A also, right? So note that under the definition, A is a subset of A also, right? So if you have two sets A and B, if you have two sets A and B, මම ගොඩාක් විස්තර කරන්න යන්නේ නැහැ. හැබැයි අවශ්‍ය ටික ඔක්කොම දෙනවා. ලොකු විස්තර සහ ලොකුට ගණන් හදන්න නෑ. හරි? If A is a subset of B, and A is, you are quite sure that A is not equal to B. A is a subset of B and A is not equal to B, right? We say if A and B are not equal, but A is a subset of B, we say A is a proper subset of B. In that case, you can drop this equal, right? We say A is a proper subset of B, and it is denoted by A is a subset of B. No equality, right? You write it like this if you are quite sure that A and B are distinct, not the same. Okay. If not quite sure, this is the notation. This is the general notation. To say A is a subset of B, right? Okay. By now you have seen that given any set A, itself is a subset. It is a subset of itself, right? It's a subset of itself. So A is a subset of A for any set A. So you are given some set A. You don't need to see the set even to give some subset. Give at least one subset of that. It is the same, right? You don't need to see what the elements in A to give one subset for the moment. That subset is the same, A, right? Right. Can't you suggest another? That means A is always a subset of A, right? Can't you suggest another such subset, which is a subset of any set? Given any set, this is a subset of that, right? There is another. There's another, which is the null set. Logically, we can prove that the null set, yes, running to says, right. The null set is a subset of any set. Take a proof එක නම් මට දෙන්න පුළුවන් නමයි. ඕගොල්ලන්ට logic කරන්නත් නැහැ syllabus එකේ මේ set theory වැඩි නැති නිසා මම දැන් ඒක දෙන්න යන්නේ නැහැ. අපි තව විනාඩි 5-10ක් ගත වෙනවා ඒකට. මම logic විස්තර කරන්න වෙනවා. මේ අර implies කියලා පිළිගන්නේ. මේක තේරුම හරියටම විස්තර කරන්න වෙනවා. ඒ proof එක දෙන්න. දැන් ඒ අපිට ඕනට වැඩි දේවල් කරන්න තරම් කාලෙකුත් නැහැනේ. I'll just write it, right, without the proof. So similarly, for any set A, the null set is a subset of A, and you call it the trivial subset. Again, a very arithmetic subset there, right? So it is a trivial subset. It is a trivial subset of A, right? Make a proper subset that visitors ගන්නා ඇතිනවා ගන්න නැතිව ඇතිනවා හරි ඒක ඕනේ ඒක proper subset එකක දාලා ගමු මෙතන පස්සේ. So this is the important thing. Given any set A, you don't need to see what the elements in that to give at least two subsets of that. Two subsets of that, right? Given some set A, without seeing the set A, you can give two subsets of the set A. They are the null set and the same set A itself, A, right? Right. Therefore, phi and A are subsets of any set A. What did you tell me? Right? Right. So we can go to the next topic, the power set. Power set of set A. Power set तो हमारा कोची नहीं है. Power set कोची थी ना. බලවේග factor. Right. So what's the power set? What's the power set of a given set A? Right. Uh, given set A, the power set of A is the set of all subsets of A. The set of all subsets of A form the power set of A, right? The set of all the subsets of A is called the power set of A. Power set of A, right? The power set of A, and there is a notation for the power set, and is denoted by PA, power set of A, right? So power set of A consists of all x such that this x is a subset of A. X is a subset of A, right? That's how the power set is defined. Right. Now I'll give an example. I'll give a question. Right. Let's say making a set theory. Example. Write down the power set of number one. A has elements P and Q. Write down the power set of this. Number two, the set B having P, Q, R as elements. Okay, write down the power sets of these two. Kadang-kadang minadi at din okay, lihat na. Minadi diyan. So what is the answer? Power set of A as we discussed earlier, even without seeing the set, you can suggest two subsets. The null set and the set is set itself. So the null set and A are two subsets, two elements of the power set, and we have more. There can be the set containing P as the only element. So this one, P, there's another which consists of Q only. Q only. So that is the power set of the set A. How is it done? Power set of B. So power set of the remember when you write power set, this has to be capital P, right? Capital P, not simple P. Simple P is written for the probability. If you write simple P, it means probability of A. Capital P says the power set of A. Okay. And for B, the power set. Again, it consists of the null set and the set B itself. In addition to them, we have the subsets containing single elements. P, only Q, only R, only P, the set containing only P, the set of only Q, the set of only R, and say P and consisting of P and Q, then Q and R, and then R and P. Right, so that's the power set. මොකක්ද මේකේ ප්‍රශ්නේ මම probability එකට capital P කියන්නේ නැහැ නේද? capital P කියන්නේ power set. අදින් පස්සේ කියන්න එපා. මොකද්ද මේ කියන්නේ PQ නෑ වැරදි නෑ in this instead of you can write P and Q PQ ඉතින් එහෙම කරදර වෙන්න ඕනේ නැති නිසා I wrote just A here instead of B You can write the set with all the elements. Right? There. Ranindu, the power set. Power set. It's a set for a set. Do you write like? Do you denote like this? Can you? A set? No. The power set is a set. Sets are given like this. The standard notation. The curly brackets, rather, curly brackets. Right? And these are also sets. These are sets, subsets of A. A is this set. The power set consists of subsets. Sets. That's why it's given as a set. This is given as a set. This is given as a set. This is given as a set. They are subsets of the given set. Right? හරි ඔතනින් සෙට් තියරි ඉවරයි ළමයි අපි පටන් ගමු එහෙම වුණොත් probability right තත්පරයක් දෙන්න ඔයගොල්ලන්ට මම දෙයක් දෙන්නම් මම එක පස්සේ පෙන්නන්න notation එක right PB के सबसेट एक නේද A PB වල A subset එකක් වෙනවා මම හැබැයි two questions I gave oh I gave two separate questions ඒ දෙක පටලවා ගන්න එපා yeah no connection between them yeah let me say what let me say is correct I gave two separate questions හරි නේද අපි යමු ඊළඟ එකට the set theory is for like this I gave in short but everything that you need then we go to the definitions of probability we start probability now we start probability now right probability now we are going to define probability but the thing is for probability there are three definitions right three definitions that's the way the theory the concepts of probability statistics developed through the time hundreds of years some centuries starting from maybe 1500 1600 times not only that means we have three definitions first what we call the classical definition the old one the theory was introduced with that at the very beginning and after not only in probability right not only in theory of probability in like almost all sections in especially pure mathematics the theories were introduced to explain the experiences or the phenomena the things the man observed happening in the nature, right? The phenomena, the practical, physical phenomena. Uh, After say some time, maybe 100 some centuries, they observed that they noted that the theory introduced previously was restricted to the phenomena, the experiences that upon which you introduced it, right? If you are going to construct something upon your experience, so your theory will be restricted to right? Restricted to your experience, right? What you have observed. Then you can't apply it in outside that broadly. Hmm? So you can't apply it broadly. Therefore, later on, not only, as I said, not only for probability, but also for other parts of, especially geomathematics also, especially around 1700 times, mathematicians started to give new definitions, new definitions to come out of those restrictions. හරි දැන් අපිට උනත් එහෙමයි නේද දැන් අපි දැන් අපේ අත්දැකීම් වලින්ම වලට සීමා වෙලා ලෝකෙ විස්තර කරන්න හදනවා නම් මේක හැම දෙයක්ම මේ මම මේ වයසට මම දැකලා තියෙන දේවල් ඕගොල්ලෝගේ වයසට ඕගොල්ලෝ දැකලා තියෙන දේවල් අහලා තියෙන දේවල් පදනම් කරගෙන මේ ලෝකෙ සිද්ධ වෙන දේවල් ගැන ලොකු විස්තරයක් දෙන්න හදනවා නම් සහ හැමදේම සිද්ධ වෙන්න ඕන ඒ විදිහටයි කියලා හිතනවා නම් ඒ තරම් මෝඩකමක් තව නැහැ. මොකද අපිට ඉදිරි අනාගතයේදී අලුත් අත්දැකීම් වලට මුහුණ දෙන්නවා. අලුත් දැනුම ලැබෙනවා. අපි තව ආයෙත් එක්ක කතා බහ කරලා අලුත් දැනුම ලැබෙනවා. යම් යම් සිද්ධි වලට මුහුණ දීලා අලුත් අත්දැකීම් ලැබෙනවා. ඒ දැනුම එනකොට අපේ දැනට අපේ තියෙන අදහස් එක්ස්පෑන්ඩ් වෙන්න අපි ඉඩ තියාගන්න ඕනේ. මෝඩ මිනිස්සු තමයි එක තැනක ඉර වෙලා ඉන්නේ. මෝඩ උද්ගච්ඡ සහ බොහොම ධර්ම මිනිස්සු. අර ප්‍රභාකරන්ලා වගේ මිනිස්සු කවදාවත් වෙනස් වෙන්නේ නැහැනේ. වෙනස් නොවි එහෙම එක තැන ඉර වෙලා ඉන්නේ මෝඩයෝ සහ උද්ගච්ඡය. ධර්ම මිනිස්සු. දැන් mathematics වල එහෙම නෙමෙයි. කාලයත් එක්ක the mathematicians noted that the existing theories, right, cannot be applied broadly because the theories were introduced upon some experiences, practical experiences, or some practical physical phenomena. Then they try to come out of those restrictions and give new definitions to come out as far as possible, right? සියයක්ම මේ අපේ අත්දැකීම් වලින් පිට දේවල් අපිට විස්තර කරන්න බෑ. නමුත් පුළුවන් තරම් එළියට එන්න ගන්න හදනවා. එතකොට ලොකු පරාසයක in a vast range you can apply your new theory, right? So that's why we have three definitions for probability. So that's the way the theory of probability developed with the time. Okay. So not only, as I said now many times, not only for probability, it's common for many parts of geomathematics. මම චිත්තට කන්නේ කිව්වේ මොනවාද? abstract algebra. වගේම අපි ඒකත් පන්තිට ඉගෙන ගන්න නැහැ. The definition of real numbers. So what are integers, positive integers? මම හිතන්නේ ඊයේ ඒ වගේ කතාවක් ආවනේ. Positive integers, negative integers. What are real numbers? ඒවා ගැන අලුත් විදිහකට බලන්න අලුත් definitions, right? දැන් චිත්තට කලින් කිව්වේ abstract algebra. එතකොට අලුත් විදිහකට follow with, right? That is introduced in not the last decade, right? Some 300 years before, the theories in mathematics introduced in a new way, right? A new vision. But still you are learning mathematics from before. These mathematics were there before around 300 years, right? ඊට පස්සේ අපු mathematics ඉගෙන ගන්න තමයි මම දැන් කිව්වේ. ඒ දේ හොඳට පාස් වෙලා ඉන්න ඕන. හරි? Like this is for the first time you are going to see a modern definition in A levels in this probability, right? For the first time a modern definition you are going to see, but that also you are not going to use much. I just give an explanation. and write the definition. Not much, right? But above A levels, you will have to learn and use them. Right. Now, the definitions. There are three definitions. और आप mechanics वाले इගෙන ගන්න යවත් එහෙමයි ආ අපි මේ ඉගෙන ගන්නේ classical Newtonian mechanics අවුරුදු 400ක් වගේ පරණ ඊට පරණ mechanics අපි මේ ඉගෙන ගන්න හොඳද මේ maths පන්තියේදී physics applied maths වලට අද ගානේ 1900 ගණන් 1900 මුලදී ආවා theory of relativity අපි ඒවවත් ඉගෙන ගත්තේ නැහැ ඊට පස්සේ 1960 ගණන් 70 ගණන් වෙනකොට 80 ගණන් වෙනකොට තවත් අලුත් theories ආවා ඒවා ගැන අපි හිතවලක් නෑ ඒක ඉගෙන ගන්න ඔයගොල්ලන්ට අවස්ථාව ලැබෙන්න ඕනේ ඒ ලෙවල් එකට පාස් වෙන්න ඕනේ even for probability the three definitions are first is the classical definition classical definition now classical definition then experimental law statistical definition ඔබ හිතන්නේ කවදාවත් ඉගෙන ගන්න ලැබෙන්නේ නැහැ කියලා දේවා maths කියන්නේ ලොකු මුහුදක් වගේ හොඳේ මහා සාගරයක් වගේ තවගල දේවල් තියෙනවා classical definition then statistical or experimental statistical or experimental definition number 3 modern or axiomatic definition modern or axiomatic so these are the things I told you axiomatic definition modern definitions you see modern definitions are almost everywhere in mathematics now pure mathematics especially eva igena ganna on for the first time you are going to see a modern definition ඒකත් යන්තම් අපි කියලා දාන්නේ right right so we are going to start by the first but before that you can take it down and then we will start by the first definition අය බබා ඔෆ්ලයින් කියලා ගියා. ඒ මොනවද කරනවද? ඒ මොනවද කරන්නේ? අය ගියා තාම ඔෆ්ලයින් කියලා. ඒකෙන් තමයි උඹ කියන්නේ. hari අපි පටන් ගමු let's start with the first definition the classical theory classical or historical theory a definition of probability right classical definition right classical definition in this you are not going to see the definition of probability at once right before that there are many things to introduce Right? After introducing many terms, we come to the term probability, right? Definition of probability. So we start by defining the term sample space. Sample space. Before that, I want to say something. In probability, uh, like we speak about the things happening in the nature, in physical phenomena, we say experiments, right? The experiments we carry out, of which the outcome is not definite, not certain, right? If the outcome is certain, then there is nothing to speak about the probability of that, right? We speak about probability of something if it's not certain. හිත උදේ ටික පායන එක ගැන ඒකේ probability එක ගැන කතා කරන්න දෙයක් නැහැ. හරි? තව කාලයක් මෙහෙම ගියොත් මේ ඊට පායද දන්නේ නැහැ. අපේ රටේ මොහොරා කාපු විදිහට මේ අවුරුදු ගානක් තිස්සේ. Anyway, uh, but you like toss a coin, right? In advance, you can't say for sure that whether it's going to be head, definitely head, or it's going to be a tail, definitely. So you can't predict like that, right? Predict means in advance, you can't say for certain, right? It's not certain the outcome. You toss a dice, a dice toss can roll. You roll a dice, the number appearing on top once it stops. So you can't give it in advance. So the outcome is not certain. So in probability, always we speak about experiments of which the outcome is not certain, right? Right. In probability, we consider experiments of which the outcome is not certain. It's not certain. So technically you say random experiments, right? Which are called random experiments. Example, tossing a coin. Example 1, tossing a coin. Tossing a coin. දැන් කවදාද තමයි අර පෞගේ කාලේ ඡන්දයක් තිබුණේ. ඡන්දෙට කලින් සමහරු ගියේ කීතියා සිවරකටම ගෝඨාවේ දිනනවා. සමහරු ගියේ කීතියා සිවරකටම සජිත් දිනනවා කියලා. ඒ කියන්නේ ඡන්දේ අදුගානේ දවස් 3-4ක් වෙනකන් there was like no certain. It was not certain. අන්තිම දවසේ දෙක වෙනකොට නම් තේරුණා මොකද වෙන්නේ කියලා. ඒ දෙන්නෙන් කවුරු දිනන්නේ කියලා. So there was a probability, right? We could speak about probability of that. අනුර කුමාරත් තියවනේ හන්දේ. එයා දිනනවාද කියන එකේ probability එක තිබුණාද? No, it was certain that he was not going to win. It's not random. අනිවාර්යෙන් පාර දිනවා කියලා අපි දන්නවා. හරි. ඒකේ probability එක ගැන කතා කරන්න දෙයක් නැහැ. අපි දවසේ ගානේ දකින්නෝනේ in politics මොනවාද ඡන්ද කිට්ටුනාම statistics everywhere. I mean, how the corona distributes. You see statistical curves, statistical like explanations everywhere. Right. So tossing a coin. So nobody can Nobody can say in advance whether it's going to be, whether it turns head or tail. Whether it turns head or tail, right? So it's a random experiment. Therefore, tossing a coin is a random experiment. Therefore, tossing a coin is a random experiment. The other example I said, Andhra Kumar winning the presidential election. So it was certainly not possible. So out of question. So it's not a random experiment. Right? Right? The sunrise tomorrow morning. It's something certain. So it's not a random experiment. Right? Example 2. The sun rises tomorrow morning. Tomorrow in the morning is a certain event. It's a certain phenomena, right? So it's not speaking about the sunrise tomorrow morning is not a random experiment, right? So it's not. Speaking about the sunrise tomorrow is not a random event, a random experiment. Hi, ඔකත් ලියා ගන්නකෝ. notes ලියන්න එනවා මේ පාරනේ. හොඳේ. මටත් වෙනකම්. set theory මේ හැටේ වෙනදට මම notes ලියන්නේ නැහැ නෝම නේද? මේකේ ලියන්න එනවා. හරිද ළමයි? ලියාගන්නකො එනවා. Right. So next we are going to define we are going to give the first definition, right? Under classical definition, as I told you before coming to the term probability, there are many things to define, right? Many terms you will come across before the term probability. Okay. First term is sample space. Sample space notation is capital S, right? So what is the sample space? Sample space of a random experiment, as I told, as we defined, explained earlier, of a sample space of a random experiment, right? We consider only random experiments. Sample space of a random experiment is you carry out a random experiment, so it's like a collection of the set of all possible outcomes. All possible outcomes. For instance, you toss a coin, all the possibilities. If you speak about all the possibilities, there are only two. Tossing a coin, there are only two: turning head and turning tail. Right? You toss a normal dice. There are six possibilities. Six things can happen. Outcomes. Turning the top number is 1 or 2 or 3, 4, 5 or 6. So that forms the sample space. The set of all the outcomes of a random experiment is called, එහෙම කියනකොට ඔයගොල්ලන්ට ගේසත් ඉගෙන ගන්න වචනයක් මතක් වෙනවද? Maybe the day before. Sample space, when I explain it like this, something should come into your mind. බලන්න මොකද්ද කියලා? Is called the sample space. Sample space of the experiment. Examples: tossing a coin once, tossing a coin, normal coin once, tossing a coin once, right? So the possible outcomes are turning head, turning tail, turning head, turning tail, right? Uh, Turning head and turning tail, turning tail, right? Uh, Therefore, the sample space S consists of head, tail, turning head and turning tail. In short, we write H and T, right? H is written for turning head. It is not written for head. H is written for turning head, right? T is written not for tail, turning the tail. Siddha Venadi, practically, right? We go to another example. Example 2. This time we say toss or roll uh, a dice, normal dice. Rolling a normal dice. Six side, a normal dice with six faces. The sample space. Sample space has the elements 1, 2, 3, 4, 5, 6, right? But there is some thing important, right? Here we are not in just set theory, we are in something more practicable, right? More practicable. So I'll take a third example also. So the sample space is not just a set. It is a set defined upon some practical experiment, something happening physically in the nature, right? In the vicinity, right? Uh, අපි බලමු, take another example. මේක හොඳට තේරුම් ගන්න ඕනේ. Example 3. So this time again you have a dice, but six faces are colored, right? Six faces are colored. The six faces of a dice are colored. Say red, blue, green,